Picture this: you're hanging out on Earth, minding your own business, when suddenly a tiny chunk of exotic matter drifts by. An ultra-dense, bizarre fragment from the heart of a neutron star. The moment it touches anything made of regular matter, the myth goes, it triggers a chain reaction that turns everything into strange matter, eventually converting the entire planet into one giant, lifeless lump of quarks. Sounds like the plot to a science fiction thriller, right? This scenario is often referred to as the killer Strangelet problem, and while it makes for a dramatic story, there's good reason to think the real universe doesn't quite work this way. Let's dive into this next entry in our Myths of Physics series and find out why killer Strangelets probably aren't knocking at our door. First, we need a bit of backstory on what a Strangelet even is. We know that all ordinary matter is built from just a couple of quark flavors, up and down. Protons are made of 2 ups and 1 down, neutrons are made of 2 downs and 1 up. But there are other quark types as well, including one called the strange quark. Under normal conditions, strange quarks are quite short-lived if they appear at all, quickly decaying into the more stable up or down quarks. So where do Strangelets enter the picture? The idea is that inside the unbelievably dense core of a neutron star, the pressure could be so immense that neutrons, which are basically up and down quarks glued together, might convert into something called strange matter. This hypothetical strange matter is a mixture of up, down, and strange quarks in a soup so dense it might be more stable than ordinary nuclear matter. If that's the case, then lumps of this quark mixture, strangelets, could potentially get ejected from the neutron star under violent conditions, such as a collision or some other cosmic catastrophe. Why does the word killer get tacked on? In the worst-case scenario, if a strangelet with just the right properties interacted with ordinary matter, like the atoms that make up your body, the walls around you, or even entire planets, it could theoretically rearrange that matter into more strangelets, triggering a catastrophic chain reaction. One by one, the protons and neutrons around it would be infected, changing them into quark matter that also contained strange quarks, until there was no ordinary matter left, only a giant, dense mass of strange matter. It sounds like a cosmic doomsday scenario. So the question is, how worried should we be? The short answer is not very. Here's why. First, physicists have spent a long time studying whether strange matter is truly more stable than ordinary nuclear matter. The consensus is that even if such stable forms of strange matter exist, they'd be extremely difficult to produce or keep around, and they might require conditions you only find in the extreme cores of neutron stars, far beyond what everyday environments provide. Sure, neutron star interiors are the real deal when it comes to pressure and density, but flinging a chunk of that stuff into interstellar space is no small feat. Second, consider cosmic rays. Every single day, Earth's atmosphere is bombarded by incredibly high-energy particles traveling near the speed of light, energies that dwarf anything we can achieve in particle accelerators. If stable strangelets could form that easily, we'd expect them to show up from these ultra-energetic collisions as well, yet we see no evidence of Earth's matter converting into strange matter after billions of years of bombardment. If it were possible to spontaneously generate killer strangelets in a chain reaction-friendly manner, nature's been trying for eons, and apparently hasn't succeeded. Third, there's a popular argument that neutron stars themselves would have been converted entirely into strange stars long ago if strangelets were truly unstoppable. Neutron stars exist throughout the universe in large numbers, some of them billions of years old. If the infection scenario were likely, we'd expect to see much fewer pure neutron stars. Many would have become strange stars after encountering a single strangelet or spontaneously forming it within. Yet neutron stars remain intact and quite neutron star-like in all our observations. This suggests that, at the very least, strangelets aren't exactly out there turning every star into bizarre lumps of exotic matter. Thanks for watching this installment of Myths of Physics. If there's another cosmic horror you'd like us to debunk, drop it in the comments. And if you enjoyed learning about killer strangelets and why they're almost certainly not coming for us, make sure to give this video a thumbs up and subscribe for more.